in today's lecture we are going to start area under curve. Basically this chapter is very simple chapter, and every year there is at least one question in JEE mains, and also there is at least one question in JEE advanced. So this chapter is very important, and it is also very highly scoring chapter. So in any question that comes from this chapter, it is easily solvable, and if you follow the basic methods you can always solve that question. Okay. So you have to make this chapter very strong. We are going to take roughly 6 lectures on this chapter, and in these 6 lectures we will focus on each skill of problem solving, because discussing theory will be just for 30 minutes probably. So I generally say that this chapter is only of 30 minutes chapter. This is a half an hour chapter, but there is a lot of problem solving skill development phase. So that is why we are taking total 6 hours. Okay. So even in today's lecture also we can finish the entire theory in 5 to 10 minutes, and later on we will spend time in problem solving only. But before we go further, you need to be very strong at definite integration, especially with the fundamental ideas of definite integration. Okay. So can we proceed? Now there is a theory point here. There is a function y equal to f of x. We want to find area formed by this function. Now whenever we say area formed by the function, we need to know the boundaries of the area. So for any region, if we want to find the area, we need to know what are the boundaries. So that is why the word is used bounded. Area bounded. So whenever that word comes area bounded, that means there are boundaries of that region. Now again, area bounded by the curve y equal to f of x. Now keep reading. All these information will give you the total boundaries that are required. In most of the cases we need 4 boundaries, but there may be some cases where 2 boundaries are enough, in some cases 3 boundaries, in some cases 5 boundaries also, it is possible. So you need to draw the graph and understand what exactly are the boundaries. So in this function, if you notice, what are the boundaries here? One boundary is x axis. So here is the x axis, this is the y equal to f of x graph. So one boundary, 2 boundaries. What is the next boundary? Ordinate x equal to a. Ordinate means perpendicular drawn to x axis. So this x equal to a is one ordinate, that is one boundary, and the other ordinate is x equal to b, that means it is this boundary. So here all 4 boundaries are mentioned. Okay. So this is how you need to think when you are solving the problem. Now look at this. So we are basically talking about area bounded by the function y equal to f of x with x axis, with x equal to a and x equal to b. Now before we proceed with the integration, we need to check once if the function is lying above x axis or below x axis. Because if it is lying above x axis, then this integral a to b f of x dx is positive, provided a is less than b. So that is also necessary here, that a is less than b. Okay. So this integral is positive if function is lying above x axis. Now similarly, if the function is lying below x axis, then integral is negative. For example, in this case, integral a to b f of x dx is negative. Okay. Now let us say we are interested in the area here. So we can straight away say that area is basically equal to this integral. So if we say this, then it is closed, area we have got. But in this case, because the function is below x axis, the output is negative. That means in out of these two, dx is positive because we are varying x from a to b. A is a small number, b is a big number. So when x is varying from left to right, dx is positive. So dx is positive, that we are clear with. If the limits are reversed b to a, then that means dx will be negative, because variable x will go from x to b, now b to a, okay. And here f of x is negative, so net result the integral is going to be negative only. So here I have explained why integral is becoming negative here. Now let us look at the area. We are interested in finding this area, but here this integral is giving us negative value, but we know that area is always positive value. So we have to multiply this with minus sign to get the area. So area is equal to minus into the integral. So we can also write this as integral a to b minus f of x dx. So in place of f of x, I have written minus f of x. Because f of x is already negative number, we made it positive by multiplying with minus sign. Earlier when it was already positive, we did not put any extra sign. So this means basically we are using the definition of modulus. That is why we say that integral a to b mod of f of x dx is going to give you the area. Now to understand this in a much better way, let us take another case. This case where graph is for some region below x axis, for some region above x axis. So that means when I integrate the function blindly from a to b, if I just integrate this blindly, of course this is not going to give us the area. Of course it is not equal to the area, because this negative value may get cancelled with this positive value, and depending on positive is bigger or negative is bigger, some value will remain, but that will not give you the total area that is required. So to find the area here, what do we need to do is, first we need to break the integral into two different integrals. So we will break it at this point where f of x is crossing the x axis. So that means I will write two integrals here, a to c f of x dx, this is one integral, and c to b f of x dx, this is another integral. Now this integral is going to be negative integral, because here the function is lying below x axis. Because the value is negative, but we are interested in the area, area must be positive. So we multiply this with minus sign and we add it to this to get the area, okay. So this way we can find the area. So here if we know for sure that the function is lying below x axis, then we can make sure that it becomes positive by multiplying with minus sign. If we do not know, then we can't do it. That is why you should draw the graph before you proceed. So in all the questions of this chapter, our first step is to draw the graph, develop understanding, develop a good understanding, and based on your understanding make a plan and then execute your plan. That is how we will solve questions in this chapter, okay. So in these three cases, we have used the idea that area is always going to be integral of y dx. This is called as the area formed with x axis. So to get area formed with x axis, we use the idea y dx. If we want to find the area formed with y axis, we will be using the idea x dy, okay. So before we go for the other idea, please make a note of this. This page also. This page also. Okay, next. Now let us look at the cases where area is formed with y axis. Now to find the area formed with y axis, the idea that we use is area is equal to integral x dy. So here this dy term dictates the primary variable. That means integral is happening with respect to y. So x also must be converted in terms of y. Even if it is not converted, we have to convert them. If it is not given, we have to express x in terms of y and then integrate. So, here that is why I have written the function as x equal to f of y. Okay, so, that means x is written in terms of y. And what are the boundaries? Again 4 boundaries must be there. One boundary is y axis, one boundary is this y equal to a, other is y equal to b. These two are the abscissa. Okay. So, here there is a mistake, it must be abscissa. Okay. So, area formed with these two, formed with y axis between these two abscissa can be written as integral a to b f of y dy. This is going to be our area. And now what about the sign? Will this give us exact area? Will this area be positive or negative? For that you need to check whether the function is lying in the right side of y axis or in the left side of y axis. If it is lying in the right side of y axis, that means x is positive. So, out of these two x dy, x becomes a positive number. And what about dy? Dy means variation in y. If y value is varying from small to high, then dy is positive. If y is varying from high to small, that means dy will be negative. So, here also a must be less than b, only then this idea is valid. So, based on graph also you can understand that a is a small number and b is a big number, that is how I have taken it. Okay. So, dy is positive, so hence the overall area will be positive here. Okay. So, this way we can understand the area formed with y axis. Now, similarly to the other case, similarly to the other situation of area formed with x axis, here also we can get two other cases. Okay. So, what is the next case? What if function is lying in the left side of y axis? So, if function is lying in the left side of y axis, our x is negative. So, in this x dy, x is a negative number, but dy is still a positive number. So, by taking this integral f of y dy going from a to b, if we evaluate this integral, it is going to give us negative value because x is negative, that means f of y is negative. So, to get the area, we have to multiply this with minus sign. Okay. So, that is why we put mod here, you know the reason, just like the other case, this case also exists. Now, what about the case where graph is taking different signs in different regions? Again, we have to break the integral. Suppose let us say this point is C, we have to break the integral as a to c f of y dy plus c to b f of y dy, and because this value is already negative, we have to multiply with minus sign, only then we will get the area. Okay. So, this way we can understand the idea of area. Suppose let us say we have a case like this. Suppose let us say function is varying like this and this is my x axis, okay, and I want this complete area. Okay. So, if this is let us say these values are a, b, c, d, and if this is let us say I1, I1 means integral 1, and between these two let us say I2 and between these two let us say I3. So, to get the area we have to do I1 minus I2 plus I3. Because this function is lying below x axis, it will give us negative value. So, we have to adjust it into positive value. Okay. So, function may take many turns also. Depending on the turns, you need to choose which ones to be put with minus sign, which ones to be put with plus sign. So, that is why graph is again very important. Okay. So, now come on, make a note of this. After this, we will start solving some problems. This page also. This page also. Okay. So now we'll proceed with some problems. So as I keep saying, in every problem, our first step is to draw the graph, develop understanding, and then based on your understanding, design a method and then use the method to solve the question. Now, if we look at this question, there is a curve given and there are three other boundaries given. So, to understand the area, we need to draw the graph first. So, y equal to x square graph is somewhat like this. Okay, this is x axis, and x equal to 1 is a line like this, x equal to 1, and x equal to 3 is a line like this. So, area must be formed between these four boundaries. So, that means we are basically talking about this area. Okay. So, because function is lying above x axis, we can proceed with the integration. Before we proceed with the integration, it's very necessary to check whether function is lying above or below x axis. Okay. So, here area will become equal to integral 1 to 3 y dx, but y is nothing but x square. So, integral 1 to 3 x square dx. So, what is the integral of x square? You know this, x cube by 3, limits must be going from 1 to 3. So, we will get 1 by 3 into 3 cube minus 1 cube, which will give me 26 by 3. So, here this is a very simple question just to explain you the concept of area. Okay. Come on, make a note of this. Okay. Now, let us look at some more questions. Find the area bounded by y equal to sin x and between these two lines x equal to pi by 4, x equal to 3 pi by 4, but area must be formed with x axis. So, how do we do that? First draw the graph. So, here graph of sin x is going to be somewhat like this. This is 0, this is pi, this is 2 pi, and we are interested in finding the area between pi by 4 and 3 pi by 4. This angle where sin x is attaining its peak is pi by 2 and pi by 4 is somewhere here. Okay. Pi by 4 is here and 3 pi by 4 is here. So, the area that is required is this area. Okay. So, we can straight away find the area by integrating because function is already above x axis in this interval. But if the interval was different, if the interval was let us say pi by 2 to 3 pi by 2 or something, then we may have to consider the negative area. Okay. So, now we just have to blindly integrate it. So, what is the area? Area is going to be integral pi by 4 to 3 pi by 4 sin x dx. Now, integral of sin x is minus cos x. So, that means it becomes minus of cos x, limits going from pi by 4 to 3 pi by 4. You know the values, cos 3 pi by 4 becomes minus 1 by root 2, cos of pi by 4 becomes 1 by root 2. So, overall we are getting 2 by root 2 which is same as root 2. So, the area here is root 2. Okay. This is again a very simple question. Come on, make a note of this. Okay. Can we proceed to the next question? Find the area bounded by this curve with y axis, x axis and y equal to 3. So, let us draw the graph here. So, here if we notice this is a quadratic in y but linear in x. So, we will write this function as x equal to y square minus y minus 2. Now, if we factorize this, it will give us two factors which are y minus 2 and y plus 1. So, basically it is going to be a parabola and axis of the parabola will be parallel to x axis. So, if we draw the graph, we may get a parabola like this and here there are two roots. Okay. One root is minus 1, other root is 2. And this is our x axis. Now let us look at the boundaries. What are the boundaries? Y-axis is one boundary, this must be one boundary. X-axis must be another boundary, this is our one more boundary, and of course curve is there, and y equal to 3 is one more boundary. Now what is the area that is bounded by these three and also the curve? So here we are finding one region here, and here also we are finding another region. Okay. So area can be equal to these two regions. Okay. So now how do we proceed with this problem? Here if we integrate the function with respect to y, that means if we find the area formed with y axis, then we can get the required regions, because here if you notice both areas are around y axis only. So we are going to use this idea that area is equal to x dy. Okay, this is the idea that we are going to use. But if you notice, for some region function is in the left side of y axis, for some region function is in the right side of y axis. So what we do here is to break the integral into two parts. Okay. So this is our y equal to 0 line, this is y equal to 2, this is y equal to 3. So we can write area as sum of two integrals. One integral is going from 0 to 2 x dy, plus the other integral is going from 2 to 3 x dy. So here second integral does not have any issues because function is lying in the right side, so integral is positive, but the left side integral is going to be negative. So this is going to be negative. So because we are interested in area, we have to put extra minus sign there. Now that's it, just we have to now integrate and simplify. So what are the functions here? So 0 to 2 y square minus y minus 2 dy plus 2 to 3 y square minus y minus 2 dy. Now we just have to integrate them and simplify. Okay. So this is going to give us area is equal to minus sign, basically I am integrating and writing. Okay. So we will get y cube by 3 as integral of y square, integral of y is going to be y square by 2, integral of minus 2 is going to be minus 2y, and limits must be going from 0 to 2. Again next one also same but different limits. So plus y cube by 3 minus y square by 2 minus 2y, and limits going from 2 to 3. Now if we simplify this, what do we get? Minus here, and when we put 2, so 2 cube minus 0 cube by 3. Similarly here 2 square minus 0 square by 2 minus 2 into 2 minus 0. Again here also 3 cube minus 2 cube by 3 minus 3 square minus 2 square by 2 minus 2 into 3 minus 2. Now we can simplify this. So what do we get here? Minus into 8 by 3, and here minus 2, and here minus 4. Here 3 cube is 27 minus 8 is 19. So 19 by 3, and here it is 5 by 2, and here it is minus 2. Okay. Now we have to further simplify this, and if we simplify we are going to get area only. Okay. So that simplification I am leaving it to you. So this is the way we find the area by breaking the integral into 2-3 parts. Okay. Come on, make a note of this. There could be a confusion that I will discuss after this. Okay. So this is the workout. Okay. Now what could be the confusion here? Here it is mentioned that 4 boundaries must be these 4 boundaries. Okay. X axis, y axis and y equal to 3 line. So that means there could also be a different meaning. For example, let us say I take green and I draw this area. Okay. So if you notice, here also the boundaries are x axis, y axis, the curve and y equal to 3. So it could also mean by the, it could also be meant by the statement. Okay. So then how to choose? In case in the exam, due to the language presented by the examiner or the one who set the paper, if you are confused about two different areas, which one to take, then you have to go for the area which is finite. So here if you observe this green region, it is going to be infinite because this is never ending, there is no boundary here, so it is not bounded region. So it is unbounded region. So hence you have to go for the bounded region only. Okay. So this way if there is any confusion, you can get rid of the confusion using simple language. But remember that in mathematics, in many chapters, because of the language presented by the person who set the paper, there could be lot of confusion. This happens at least in the practice. But in IIT papers, generally that confusion is not there. But in case there is an ambiguity, of course there will be bonus. But mostly 99% of the time ambiguity is eliminated in IIT papers. So probably in books or probably in lectures also, teachers due to their language problem, they might not be able to present it properly. But in case if there is any confusion, remember that area should be bounded, okay, or area should be finite. Okay, can we move on now? Next, find the area enclosed by the curve with its lattice rectum. So here this is going to be a parabola, assuming that a is a positive value. So this is going to be a parabola like this, and this is our y axis. This is the lattice rectum, this is the focus a comma 0, and this is the lattice rectum. So even if y axis is not there, if you observe, area must be enclosed. Okay, so here what is given? Enclosed is given. Enclosed means it must be a closed region. It should not be open-ended region. There could be regions where area is bounded, but it is not an enclosed diagram. It is possible. So if word enclosed is mentioned, that means diagram must be closed. So here what is the closed diagram between the lattice rectum and the parabola? This is the closed diagram. Okay. Now we want to find this entire shaded region, but I have marked two different regions here. Why? Because there is symmetry. So to find the area of the entire region, I will just find only one region. I will multiply that with 2, that will give me the required area. Okay. So here we can say that area is equal to 2 into integral from a to where? From 0 to a, and with respect to x I want to integrate, so it becomes y dx. Okay. So further 2 into integral of 0 to a, in place of y we can write it as root of 4a into root of x dx. So further when I simplify, I will get 4 into root a into, what is the integral of root x? It is x root x divided by 3 by 2, limits going from 0 to a. So this is going to give me 4 into root a into 2 by 3 into a root a minus 0. So further it will be 8 by 3 into a square. So this will be our required area. Okay. So this way we can calculate the area. Okay. So can we proceed to the next question? Before we proceed, there could also be different ideas. For example, this. Let us say you want to integrate this with respect to y. So if you integrate it from this limit to this limit, what is this value? Because you know the coordinates of this point, which are a comma 2a. So this is y equal to 2a. So from 0 to 2a, if you integrate with respect to y, so 0 to 2a we are integrating x dy. If we do this, we will get this area, which I marked in red. But we are interested in this area. So that means to get this blue area, we have to subtract this red area from rectangle. Now what is the area of this rectangle? Base is a units, height is 2a units. So that means from a into 2a, this is the area of the rectangle. If I subtract this integral with respect to y, I will get this blue region, but because I am interested in this complete blue region, I have to multiply that with 2. So here multiplying with 2 will give us the area. Okay. So this way also we can solve the problem. Okay. So depending on whichever is the method that you are comfortable with, you can solve it, you will get the answer. Okay. So here if you observe, there could be two ideas always with respect to x or with respect to y, but you choose the method which will give you the fastest answer. Okay. Come on, make a note of this. Okay, can we proceed now to the next question? Find the area enclosed by that curve and x-axis. So here also again area should be enclosed. Now if you look at the curve, what kind of curve is this? It is going to be a parabola like this. And what are the roots of this? It can be factorized into x minus 4 and x plus 2. There are two factors. So if I take x-axis here, so I will get minus 2 here and 4 here. These are the roots. Now irrespective of whether y-axis is in the left or right in the middle, it does not matter here. We are interested in only area enclosed by these two. So if we are using area with x-axis, we are not interested in the location of y. If we are doing area with respect to y-axis, we are naturally not interested in x-axis. Okay. So here because the curve is lying below x-axis, so integral must be negative. So area is equal to minus into integral minus 2 to 4 f of x dx, which is same as x square minus 2x minus 8 into dx. Okay. So if we simplify this, we will get the required area. So let me just do the integration here. So minus into x cube by 3 minus 2 into x square by 2 minus 8 into x, limits going from minus 2 to 4, 2 are getting cancelled here. So what do we get? 4 cube minus minus 2 cube. So 4 cube is going to be 64. So I will directly write 64 minus minus 2 cube is minus 8 divided by 3 minus 4 square minus minus 2 square minus 8 into 4 minus minus 2. Now we have to simplify this. So what do we get here? Minus into 64 plus 8 is 72, 72 by 3 is 24, minus here 16 minus 4 is 12, 8 into 6 is 48. So what are we getting? 12 plus 48 is 60, 60 minus 24 is 36, minus 36 into minus sign, it is going to give you plus 36. So whenever we write the answer, we have to write square units. Okay. So because we do not know the units, whether it is meters or centimeters, we always mention units. Okay. So square units means, of course, we are talking about area. Cube units means we are talking about volume. Okay. Come on, make a note of this. Okay, next question. Find the area bounded by this curve with x-axis. That means area must be bounded between these two only. And looking at the function, function is written as minimum of two other functions. So whenever there is a minimum of two other functions, if those two other functions are constant functions, then it is easy to handle. But if those two functions are variable functions, then how to choose which is minimum, which is maximum? For that you again need graph. Okay. So, here it is already mentioned that we want the area in the interval 0 to 1. So, we can draw the graph only between 0 to 1 by substituting values also, okay, because the interval is a very simple interval. So, we can just substitute values and do it. Okay. So, let me first draw the graph of first function, which is the bracket x. You already know that function. So, it will start from 0 and go like this. This is fine. Okay. And again at 1 we will get the value at 0 only. So, at 1 also output is 0. This is the graph of first function, which is our bracket x. What about bracket of minus x? That also can be drawn by substituting values. If I put 1, what will it give us? Bracket of minus 1 is 0 only. So, the point is here. If we put 0, the output is 0 only. So, the point is here. Now, point is here. Now, if I put any other value, let us say I put 0.9. So, bracket of minus 0.9 will give me 0.1. So, here the output is 0.1. Similarly, let me put 0.1 also. Bracket of minus 0.1 will be 0.9. So, the graph is going to be exactly reverse of this. Okay. Now, look at these two. These two functions are intersecting at one point. Okay. So, this one point is where both values, both outputs are equal. That is going to be 1 by 2. Okay. So, this is exactly 1 by 2 and the height is also going to be 1 by 2 here. Okay. Now, from 0 to 1 by 2, out of these blue and red functions, blue is minimum, and from 1 by 2 to 1, out of these blue and red functions, red is minimum. We are interested in finding the area of only the minimum of these two functions with x axis. That means we are basically interested in this region. Now, because the region that we formed is a simple triangle, we can use the area of triangle and solve it. So, here the area is going to be half into what is the base length, which is 1 unit, what is the height, 1 by 2. So, the answer is going to be 1 by 4. Okay. Now that we have written these two functions, I will also talk about one simple tip here. If we have the function y equal to bracket x as this. Okay, so let us say this is minus 2, minus 1, 0, 1, 2, 3 and this is bracket of x. If we are interested in bracket of minus x, so between this function and y equal to bracket of minus x, what is the difference? In place of x, minus x is coming. So, in place of x, if minus x comes, graph will get reflected about y axis. So, that means here the graph will look like this. If we take this as y axis and this as x axis, graph will look like this. Okay. So, if you notice, we have just reflected this graph about y axis to get the other graph. So, here when we draw the graph, we cannot always go for substituting values and getting the graph, because if the function is a little complicated, then it may confuse you definitely. But then if you remember this idea that in place of x, if minus x comes, graph gets reflected about y axis, maybe you can do it faster. Okay. Come on, make a note of this. Okay, can we proceed to the next question? Okay, next question. Find the area consisting of all points in the set. There is a set contains all ordered pairs x comma y and x and y are satisfying this relation. So, whenever you see such kind of relation which involves inequalities, then you go for the extreme cases with equality and draw them first. Go for the extreme cases with equality and draw them first. So what are the extreme cases here? Y equal to x square is one extreme case and y equal to 3 is another extreme case. So y equal to x square is a graph like this, it is a parabola. Y equal to 3 is a straight line like this, and let us assume that x and y system is somewhat like this. Okay. Now here we do not actually need the location of x and y axis, we are interested in only this region. Okay. So how do we do that? So to do this, what we do is we try to understand the inequality first. Y must be greater than equal to x square. You have understood this in coordinate. If this is, let us say, y equal to f of x, all the region which is above this curve will be y greater than f of x, and all the region which is below will be y less than f of x. You know this idea. So which means we are basically interested in the region which is above this curve y equal to x square, and y also must be less than equal to 3, that means we are interested in the region which is below this y equal to 3. So that means we are basically interested in this region. Okay. Now how do we find this area? To find this area there are two ideas. One idea is our regular idea. Let us say this is our x axis, this is our y axis, and if I blindly integrate the function, if I blindly integrate the function, which area will I get? So if I integrate the function directly, I may get this area, okay, this dotted area I may get, that is with respect to x. If I integrate with respect to y, I may get this area, that is possible. So which one do we choose here? It is your choice. If you go for the dotted area, we may have to subtract it from the rectangle, so 1 or 2 steps may be extra. If we go for the integral with respect to y, you can directly get it, so it is your choice. So you can do it however you want, at the end you will get the same answer. But here I am doing it with respect to y. Okay. So here I will first get this area and then I will multiply that with 2 to get the total area. So because the curve is in the right side of y axis, so I can straight away say that this is limits going from 0 to 3, that means this is y equal to 0, x axis is y equal to 0 and the point, and the other abscissa is y equal to 3. So between 0 and 3 I am doing x dy, and if I multiply this with 2, I will get the required area. This is my plan and I am going to execute the plan. So because here if we look at this curve, x is equal to root y, so we have to put root y here. Now let us just find the integral here. So it is going to be y root y divided by 3 by 2 and limits going from 0 to 3. So which is going to be 4 by 3 into 3 root 3. So the answer is going to be 4 root 3. Okay. This way we can calculate. But there is another idea. Another idea is this. We have one curve here, we have one line here, y equal to 3. Okay. And this is my x axis. At any point x comma y, let us say it is on the curve. Okay. And this height, if the input is x, the height is going to be f of x. Now if I subtract the height from 3, that means if I do 3 minus f of x, I am going to get this height, and dx is anyways varying in this direction, this is our dx direction. Okay. So that means if I take 3 minus f of x and integrate it from these two values, this boundary and this boundary, then I am going to get the area. This is another idea. Okay. So basically what I am doing is this. I am taking these small strips. Okay, I am taking all these small strips and I am adding them. Okay. So you have learned how to add such small strips in physics also. It is just like that. Okay. So if I integrate this from appropriate limits, for appropriate limits, it will give us the area. Now how to get these appropriate limits? We know that this curve is y equal to x square and we want this y to be equal to 3. So basically I am solving these two. So this value will be minus root 3 and this value will be plus root 3. So that means limits will be going from minus root 3 to plus root 3. Also we can notice that this is symmetric about y-axis. So if I just do it from 0 to root 3 and double it, then also it is fine. So I can also write this as 2 into 0 to root 3, 3 minus f of x. That means what is f of x here? 3 square dx. This way also I can get the area. So let me just simplify it and show it to you. So integral of 3 is going to be 3x minus integral of x cube is x square is x cube by 3, limits going from 0 to 3. So this is going to give me 2 into 3 root 3 here minus 3 root 3 by 3. So here 3 is getting cancelled. So we got 2 into 3 root 3 minus 1 root 3 is going to give me 2 root 3, which is again 4 root 3. So this way also we can do it depending on the situation. So here I have just given you one idea. We can also expand this idea into a different method in the next lecture, but here this forms the basic theoretical understanding of that method. Okay, come on, make a note of this also. So this method and also this note. Okay, come on. Okay, so next question. So here there is a function given y equal to f of x, which has these conditions, and area bounded by that function between x equal to 2 and x equal to 5 ordinates and bounded with x axis is given as 12. Find the area bounded by f inverse of x. So we are looking for the area formed with x axis by f of x and also by f inverse of x. So how do we do it? So to solve this there are two ideas. Idea 1 involves the understanding of the function. Idea 2 involves formula. Let me explain the idea 2 first. Okay. So here idea 2 goes like this. There is a standard formula. This formula we have studied in definite integration. So integral of a to b f of x dx plus f of a to f of b f inverse of x dx is given as this. So what are the values given? F of 2 is given as 2 and f of 5 is given as 5. So that means we can apply this and write a statement like integral of 2 to 5 f of x dx plus, and f of 2 is 2, so this also becomes 2, f of 5 is also 5, it becomes 5, f inverse of x dx must be equal to 5 into f of 5, which is 5, 2 into f of 2, which is again 2 only. So this is the formula, we have directly applied the formula. Now also here it is given that there is one more information. So as I keep saying, beta everything is about data, do not miss any data. So what is given? Area formed with x axis, that means integral 2 to 5 f of x dx is already given as 12 units. So integral 2 to 5 f of x dx is given as 12 units. So that means we can put this value here directly. Okay. But here I did not check if the function is lying below x axis or not. I did not check. I will answer that little later. So I will put 12 here. For this value I will put 12 plus This is the area that I am interested in, and here it is 25 minus 4, which is 21. So to get the area, I can do it as 21 minus 12, which is going to be 9. So 9 should be the answer. This is the method. Now I will come to the explanation. So as I keep saying, in coordinate also I kept saying that for every algebraic expression there is a geometric meaning, for every geometric orientation there is an algebraic expression. We understood all of that. Here also for every step we are writing there is a logical meaning. So now here 2 to 5 f of x dx is 12, and I did not mention if the function is below x axis or above x axis. What if some part is getting cancelled? How did I directly conclude that integral is going to be area only? Because we will start the construction of idea like this. Because here both f and f inverse are directly involved in one single integral, we have to assume that f inverse must exist. That means inverse function must exist. For inverse function to exist, function must be a bijective function. Let us look at the outputs here. Okay, so let's draw the diagram here once and explain it. So let's say this is my y axis, this is my x axis, and this is 2, this is 5, this is y equal to x line. There is one point here and there is another point here. So I'll just take another diagram here because we need all of them. So let's say there is 2 here, there is 5 here. At 2 we have one output which is positive, at 5 also we have one output which is positive, and of course here output is higher, here output is lower, and function must be bijective function. That means function cannot take any turns, that means derivative must never be 0, function must be strictly increasing function. So from 2 to 5, if the function has to progress and also it has to be strictly increasing, so it must be like this or like this. There are only two ways of possible cases here for the function. Now out of these two, if you again take that possibility of function going below x axis, it has to somewhere make a turn and come back. So if you are taking a possibility of function going below x axis and coming up, function has to turn somewhere, but if it turns then derivative becomes 0, function becomes non-monotonic function. So hence for inverse to exist, this function must lie above x axis only. So which means this is going to give us the area. So we used it correctly. Now let us take that same discussion and solve the same question. Let us take the same discussion and solve the same question using the first idea. So here what is the discussion? Discussion says that function must be bijective, and because both outputs are positive and because final output is higher than the initial output, function must strictly increase. So either it must be this kind of graph, which kind of graph? This kind of graph, or it must be this kind of graph. Only two graphs are possible. Okay. So now out of these two you can take any graph, it is your choice. So here I am taking a graph like this. This is my graph of f of x. Okay. So if this is my graph of f of x, what will be the graph of f inverse of x? So the graph of f inverse of x will be reflection of this graph about y equal to x line, and in fact joining these 2 points is only the y equal to x line. So this is my graph. Okay. So let us take this as y equal to x line. So now let us draw these graphs one more time for clarity. So original function is in blue. Let us say this is my graph. Okay. And this is the 2. And what about the inverse graph? Inverse will be reflection about this with respect to y equal to x line. And now let us look at the area. What is the area of f of x formed with x axis? Okay, so it has to come in blue. area formed with f of x with x-axis of f of x between the ordinates 2 and 5 will be this area. Okay. Now, what is the area formed with in x-axis by the inverse function? So, it is this area. Okay. Now, let us look at this red area and try to connect this with this diagram. We already know that the output here is 5, the output here is 2. Now, if we look at the next diagram and we are interested in this red area, that red area is same as this red area. Okay. So, I hope you are able to understand this directly. Okay. Now, again, now looking at this diagram, we can understand that using this blue area only we can directly calculate red area directly. Okay. Of course, we can calculate that because this area is already given as 12 units. So, how do we do it? If we just look at this diagram, okay. So, I will just remove this for space. If we look at this diagram looks like this. Okay. And this is 2, this is 5. So, this gap is 3 units, the height is 5 units, this is 5, this is 2, this gap is 3 units. Now, from this area, if I subtract this blue shaded region, I will get the red shaded region. Now, how do we get this area? We can draw a line here and form 2 rectangles, or we can also do this idea that big box minus this small box, that means I am subtracting this part, that will give me the required area, which is this area. We can also use this idea, whichever you are comfortable with, and here just get this area and subtract the blue shaded region. Now, what is this area? See, if we complete this rectangle, so the overall area of the square is going to be, required area is equal to, overall area is going to be 5 into 5 minus this small square's area, it is going to be 2 into 2, and from this area we have to subtract that blue area, which is going to be 12, which is already given. So, this is going to give us the same number which we have done in the last case. So, now if you notice this, what exactly are we doing here? This expression is nothing but finding the area of this region, Okay. So, that way we can solve this problem. Okay. So, I hope you have liked this solution. So, here I have given you the proper method. Okay. So, if you look keenly, if you go in depth, you can understand it very, very nicely and you can remember it forever. Remembering formula will not develop your skills, but these kind of techniques will develop your skills. Okay. So, this is fine. So, now here I have just assumed this blue curve, I did not take this curve. Why? Because if you just take this trapezium, this is 2, this is 5, this is 2, this is 5. Now, what is the area of this trapezium? This gap is 3. So, it is going to be half into h into a plus b, which is going to be 21 by 2. This is definitely less than 12. So, because in the function the area is given as 12, which is more than half of this area, that is more than the area of the trapezium, I took the function above y equal to x line. Okay. So, this is the idea, that is why I have taken the curve as above y equal to x line, I did not take this curve. But even if you take the below curve, it does not matter, you will get the correct answer. Okay. So, with this we will close today's lecture. I hope you have liked the discussion and I hope you are liking the lectures.